For years, artificial intelligence lived on screens as a passive experiment. Today, its reality is built out of concrete, steel, and industrial-scale cooling systems. Global markets are currently pouring $2.9 trillion into data center construction. This massive capital flood has triggered a fierce geopolitical race for semiconductor chips, pushing nations to physically host their own models to secure domestic AI sovereignty. This diagram contrasts the legacy surface code grid with IBM's Bivariate bicycle code. Systems now fix errors faster than they occur, using a fraction of the hardware. Because of this tenfold reduction, by 2029, hybrid quantum facilities will render older computing models obsolete. Generating this level of compute power carries an immediate physical cost. AI data centers now draw the electricity equivalent of entire industrialized nations, putting legacy power grids under severe threat of collapse. This chart projects the rapid financial response to that grid instability. To prevent catastrophic failure, the market for physical AI, hardware that embeds autonomous intelligence directly into the energy grid for real-time load balancing, is scaling at a 32.8% annual growth rate. Industrial expansions of this magnitude are macroeconomic earthquakes. They demand a ground-up recalibration of how and where global capital is allocated. The driver of this physical build-out is the rise of agentic AI. Instead of algorithms sitting idle waiting for a human prompt, these systems act as autonomous agents that sense their environments, make decisions, and execute complex workflows on their own. On the manufacturing floor, this agency translates into machines that read their own telemetry. They detect component wear, autonomously negotiate with suppliers to order replacement parts, and deploy mobile robotics to handle logistics without human intervention. This convergence of digital systems and physical reality extends directly into biology. In agriculture, ecological AI platforms are ingesting massive datasets to predict destructive pest outbreaks, like the western flower thrip, weeks before a single crop is damaged. In pharmaceuticals, the traditional decade-long process of testing single protein targets has been bypassed. Advanced models are now mapping complex multi-driver diseases simultaneously to identify the exact combination of therapies needed to reverse cellular dysfunction. By utilizing computationally designed treatments, leading biotech firms are pushing drugs for complex autoimmune and oncology conditions into active human clinical trials in under 3 years. Across physical and biological industries, capital has shifted away from academic theoretical models toward verified autonomous systems actively executing real-world solutions. In urban environments, developers are mapping entire city blocks into massive digital twins. These virtual replicas allow governments to autonomously simulate and optimize traffic patterns and grid distribution over decades of projected wear. When applied to commercial real estate, these real-time demographic and historical data feeds strip out human bias. Subjective appraisal has been replaced by instant, algorithmic property valuation based on verifiable data streams. This data-first architecture dictates consumer behavior through the emergence of agentic commerce. Currently, 58% of millennial and Gen Z demographics explicitly trust AI agents to compare prices, analyze product features, and execute daily purchases on their behalf. For legacy retail brands, this creates an immediate threat. If a company's product metadata isn't perfectly structured with highly semantic summaries for an AI to parse, the algorithm skips them. They effectively vanish from the marketplace. Commercial survival relies on a brand's ability to format its reality. If the algorithms cannot read and select the data, human consumers will never see the product. This structural shift scales to high-end intellectual labor. In education, tech vendors are establishing unified platforms that ingest proprietary student data to predict failure risks and manage the academic lifecycle autonomously. The disruption is even more aggressive in the legal sector. Routine litigation tasks like document review and discovery that used to take 16 billable hours are now completed by AI systems in under 3 minutes. This graphic shows the 80-20 inversion. While the top bar shows 80% of time on information collection, the bottom flips to strategic analysis. Elite firms aren't lowering prices. By dedicating time to high-value strategy, they justify significantly higher hourly rates. Artificial intelligence weaponizes elite knowledge work, granting massive financial and structural advantages to the firms that deploy it. The capital required to evaluate and deploy these proprietary models provides a structural advantage to the largest global firms, threatening mid-sized competitors who lack the financial depth to compete. The global economy is sharply bifurcating. Companies clinging to static, legacy software architectures that cannot integrate with modern data endpoints are becoming toxic assets inside institutional portfolios. Over 70% of enterprise modernizations fail, primarily due to replication bias. Instead of designing for new operational realities, organizations waste capital rebuilding obsolete systems. Executive capital allocation now carries a dual mandate. Investors must divest from rigid legacy systems and redirect growth capital into the sustainable infrastructure required to support LLMs and hybrid quantum nodes. Yet, as autonomous agents absorb the physical and digital workflows of the modern world, a remarkable paradox emerges. The highest financial and strategic premiums are increasingly placed on things that algorithms cannot replicate. Recently, a major institutional fund redirected $1.2 billion into a unique hybrid portfolio. They paired sustainable tech infrastructure directly with large-scale human-driven public art collectives. To survive the computation era, leadership must build the autonomous infrastructure of the future while fiercely protecting the uniquely human elements that give that infrastructure its purpose.